Bismillahirrahmanirrahim. Dear students, here we have to solve example 2, page 423. This is an example at page 423 of mathematical technique. Solve this differential equation rearranging the given equation we have. These here p square will be multiplied with the bracket. Similarly, p will be multiplied with the bracket, and we will get this equation. Now we have to take minus y common here. We will get minus y into p plus 1, and if we take that term to the left side, then we will get y into p plus 1 is equal to this one. This is the equation obtained from this equation. Now dividing, now taking common here, we will take common here, xt is common, so we will get p plus 1 minus ap square. Now this is an equation. We have to solve both sides by p plus 1. If we divide both sides by p plus 1, then p plus 1 will be cancelled here, p plus 1 will be cancelled here, and here this will be divided by p plus 1. This is an equation of the form y is equal to px plus f of p. So it is Clairaut's equation. Hence its general solution is obtained. If we replace p by c, then we get the general solution. So this is the general solution of the differential equation. This one, we have converted this differential equation as Clairaut's equation, and then we have replaced p by c to reach the general solution. Equations reducible to Clairaut's form. Now here we have to discuss those differential equations which are reducible to the Clairaut's form. There are certain differential equations which can be converted to Clairaut's form by means of suitable substitutions. For example, the equation of the type. The equation of this type can be reduced to the above equation can be reduced to the Clairaut's form by making use of the substitution. If we use the substitution, then such type of differential equation is converted to the Clairaut's form. This equation is here is y square. Here we have p times function of xy, plus here we have function of p xy. So such type of equation can be converted to the Clairaut's form by using y square is equal to v and x square is equal to u. Another type is the equation of the type. We have another type. This is another differential equation. And here this is ax. Here the misprint is ax. This is an equation e power by a minus bp is equal to f of p e power by minus ax. Equation of this type can be transformed to the Clairaut's form by the substitution. Such type of equation can be converted to the Clairaut's form by using substitution. E power ax is equal to u, e power by is equal to v. So here we have two types of differential equations, and both the differential equations can be reduced to the Clairaut's form by using either this substitution or by using the below substitution. Now here we come to an example. Here we have example 1. Reduce this differential equation to the Clairaut's form by making use of the substitution x square is equal to u, y square is equal to v. This is a differential equation, and we have been asked to reduce it to the Clairaut's form by using the substitution. Solution. Since x square is equal to u, y square is equal to v, taking differential of these two equations, we get 2x dx is equal to du. Similarly, differential of the second equation is 2y dy is equal to dv. Now we know that p means dy by dx. Now putting value of dy, The value of dy from here is obtained here. Similarly, value for dx is obtained from here. And after simplification, this p, which is actually dy by dx, and its value is equal to x divided by y dv by du. So we have to remember this result. This p will be replaced by this value. P is equal to this one. Substituting this value of p in the given equation reduces to, now putting the value here in this differential equation, here we have p, here we have p, similarly here is another p, and here is another p. We have to put value of p, this one, into the differential equation. So here we see the putting this x will be multiplied with this x, and we will get this term. This minus y will be as it is. Now p, this p is actually this one, so this y and this y will be cancelled, and we will get this term. Similarly, x will be as it is, and here we have to put value of p. So here we see value of p. Now this is a differential equation. We have to simplify, multiplying both sides by y. If we multiply both sides by y, this y will be cancelled, this y will be cancelled. Similarly, if we multiply both sides using multiplication to the left side, this y will be cancelled, and this y will become y square. Similarly, if we take x common here, then that x, then the common x will be cancelled with this one, with this x, and we will get this differential equation. This is the differential equation denoting dv by du by p. If we denote dv by du by p, this p is different from this p. This p and this p both are different. So we have to replace dv by du by this p, and we will get x square. This is x square. This is p, x square p. This is y square. This is p. This is plus 1, and here this is p. This was the result. Now we have to replace x square by its value u, y square by v. So this is the equation. Now dividing both sides by p plus 1. If we divide both sides by p plus 1, here it will be cancelled, and here it will be divided by p plus 1. Now isolating p, v, this v will be taken to the other side, and it will become v, and here this term which have been divided by p plus 1 will be shifted to the left side to this term, and finally we will get this equation. This is the equation obtained by rearranging and simplifying this differential equation. If we look to this differential equation, this is Clairaut's form, and hence by changing p to c, the general solution is this, replacing here p by c, and so the general solution of this Clairaut's equation will be this one. This is the general solution in terms of v and u. Now replace v and u by its actual value, that is y square will be equal to cx square minus a square c divided by c plus 1. This is the general solution of the given differential equation, which have been reduced to the Clairaut's form. Now we come to the last example. Example 2. Solve e power 3x p minus 1 plus p cube e power 2 is equal to 0. Rearranging the equation, if we take this term to the other side, it will become negative. If we take common, if we take minus common from this side, or if we multiply this equation by negative sign, so here p minus 1 will become 1 minus p, and this negative sign will become positive, then multiplying both sides by e power 3x. So on simplification, e power 2y divided by e power 3x will become e power 2y minus 3x. This is the solution. Now multiplying this equation by e power y, if we divide this equation by e power y, and here e power y will be simplified with e power 2y minus 3x, and thus it will become e power 3y minus 3x. यहाँ पे जो e power y है वही e power y e power 2y minus 3 के साथ ऐड होकर e power 3y minus 3x बनेगा. Now writing this side is Clairaut as cube of p e power y minus x, we can take this 3 and 3 times y minus x as this 3. We can write this this right side as cube of this one. Here we get e power y 1 minus p is equal to p e power y minus x 3. Here we see e power y minus x. Let e power x equal to u, e power y is equal to v. If we divide v by u, then value of v and u are here, e power y or e power x. This will be equal to e power y minus x is equal to v by u. So this will be replaced by v by u. Now we have to further write this ex u ey is equal to v. On taking differential will become e power x dx is equal to du, e power y du is equal to dv. We know that p is equal to dy over dx. Putting value of dy, so this is dy which is here, so we can find value of dy from this equation and we will substitute here. Similarly this dx is here, so we will find value of dx from here and will substitute here. So this is the simplification. Now ex over ey is equal to u divided by v is equal to dv over du, and dv over du can be replaced by p, where p is equal to this one. Here we have 2p, this is 1p, this is another p, both the p's are different. So value of p, this is p which is equal to this one. This p is equal to p dv by du. This p is equal to dy by dx, and after simplification it equals to this side. Now if we take negative from here, it will become e power y p minus 1, and here will be negative. If we take this negative term to this side, then it will become this equation. Now putting value of e power y is equal to e power y equal to v. So here we will get v. This is p, and the p is here, whose value is here. So putting the value for this p, the value is this one. This is the value. So we see its value. Similarly, this p is equal to, this is p whose value is here, e power y minus x. This is here we see e power y minus is equal to v by u. So for this we put v divided by u, and this p is equal to u over vp. Now simplifying, taking this v inside, this v and this v will be cancelled, and this v into and minus 1 will be equal to v. V will be cancelled, this v and this v will be cancelled, this v will be multiplied here, so this will be v. Similarly, this and this both will be cancelled each other, p power 3 will be here. Now isolating p, this v can be shifted to the right side. We get v equal to up plus p cubed. Now this is our differential equation. This differential, we see this differential equation here. So this differential equation, this one is a Clairaut's form. This v is dependent variable, this u is independent variable. So it is Clairaut's form. Hence the required general solution is v. Replace p by c. This is the general solution. Now putting the original value, v is equal to e power y and u is equal to e power x. So this is the general solution for the given differential equation, which was converted to the Clairaut's form by using some substitution.